Alright, let's go ahead and see what is the optimizers in the deep learning. In previous lesson, I told you the momentum is used to improve the speed of convergence. So the momentum says that how fast your model is converging. So that is also here known as the optimizers there. So this optimizers also tells you, in fact, optimizers are a function there which actually improves the convergence rate there. There are many type of the optimizers, like you have the SGD, which is the Stochastic Gradient Descent, you have Adam Optimizer, you have RMS Prop, you have AdaGrad, you have AdaDelta, you have NADM and FTRL. So these are the optimizers. In generally we use Adam or the Stochastic Gradient Descent optimizers. These are very fast optimizers here. So these optimizers are used along with the loss function, and then these optimizers are adjusted in such a way that your model can achieve their lowest error. Suppose that this is a loss function, your loss function is there, and then this is the plane of your loss function there. Alright, and you start your training from this particular point. Your goal is always to go deep down in somewhere in the valley. So this valley says that how low error you can achieve there. Alright, so if you start somewhere here, then obviously you don't need to go upward, because if you go upward, that means you are increasing the error. So you need to come here downward. So this plot which you are seeing here, this surface plot, this plot is actually the loss function plot or loss method plot there. Alright, and this optimizer makes sure that you comes to the valley in a fast way. And other than that, optimizer also makes sure that you doesn't end with these local optima or local minima. Why this is local minima? Suppose that if you follow some path and you get stuck here, then there is no way to move and come here. Because if you stuck here, then you need to go upward to come here, and your algorithm avoid going upward in any time. So if you end up here, then obviously your algorithm is not optimized there. Even if you end up here or any other places, then your algorithm is not optimized. So this optimizer makes sure that you follow a correct training path, a correct optimization path, so that you can achieve there a minimum error there. Something like this. So let's go ahead and see what is the gradient descent. So this descent says that it is something descending, that means coming down. So the gradient descent is an optimization algorithm used to find the values of the parameter of the function that minimizes the cost function. Okay, so this is a huge sentence. Let me break it down for you once again. As I told you earlier, there is a loss function. So the loss function says that how much error you are getting at the output. So our task is to optimize the error given by that loss function, which compares the predicted value minus output. So if predicted and the predicted and the target value is exactly the same, then the loss function will be giving us the 0 result there. That's what we want. So the method which is applied there to improve that loss function, that is known as the gradient descent there. This is one of the other method. Then you have here stochastic gradient descent. So this is also an iterative method for optimization, and this method also takes their small subset of your data for the optimization. So this is kind of the randomly selected subset of the data in case of the stochastic gradient descent. If we talk about the general gradient descent, in that all data is taken at once. But if you take all data at once, then it really becomes difficult to calculate the loss function for all data at once. That means then the training becomes there, then training becomes slow there. It takes a lot of the time. That's where we use a stochastic gradient descent. It actually takes some input data randomly. Alright, so every data says that different direction to move to avoid to lower the error. Since it is randomly chosen, and by the theory, by the virtue of the central limit theorem and the normal process, we know that if we select the random samples, then whatever the true properties of the data, that will be shown by those random sample. That means, let's say if you have 1 million data sample and you had chosen just a small subset of the data, so with that small subset of the data, you can find out in which direction you need to move so that you can reduce the error. That is the stochastic gradient descent there. Then we have here a mini batch gradient descent. This is again a variation of the gradient descent algorithm, which computes these gradient descent on the small batches of the training example. Earlier I told you that the stochastic gradient selects the data points randomly, but in mini batch gradient, these batches are already defined during the training. So based on those small batches, these loss functions are calculated, or you can say the error is calculated, and based on that, the back propagation is done to adjust the weights of the neural network. Alright, so this is all about in this lesson. I'll see you in next one.